Okay, I think we're ready to add and subtract with unlike Radicands. So here's my expression. Square root of 8 minus square root of 9 plus square root of 18 minus square root of 81. So I see my operations add and subtract, and the first rule that comes to my mind is a basic rule. To add and subtract in real world, your terms, everything has to be alike. These are not alike, even though they're all square roots. They don't have the same radicand inside the square root symbol. So none of these are alike, so we cannot do addition or subtraction. So what we have to deal with are the roots. We have to simplify them. So because we're dealing with square roots, I'm going to focus on my perfect square list up here. So I have a square root of 8. Well, if I look at my list, is 8 on that list? No, 8 would be right here, between 4 and 9. What perfect square divides into 8? 4. So we would rewrite this as the square root of 4 times 2. Which of these numbers can we square root? That's right, the 4 we can because it's a perfect square. What is the square root of 4? It's a 2. That's why it comes out. We did the operation. Can we square root the number 2? No. 2 is not a perfect square. It's in lowest terms, so we leave it inside. So the square root of 8 is simplified to be 2 square roots of 2. All right, bring down our minus. Now I have the square root of 9. And everybody look at me. What do you know about 9? 9 is a perfect square, which means there's no work. You know the answer to this. What times itself is 9? Well, that's easy. That's 3, the whole number 3. So we're done with that. Bring down our plus. Oh, I have the square root of 18. I look at my list. Nope, 18's right here. It's not a perfect square. What's the biggest perfect square that divides into 18? Oh, 9. So we're going to rewrite this as 9 times 2. What is the square root of 9, everybody? 3. So a 3 comes out. Can we square root the number 2? No. 2 is not a perfect square. So it stays inside the symbol because we cannot do that operation. Bring down our minus sign. We have the square root of 81. We're doing a square root. Is 81 a perfect square? Sure it is. 81's right there. So there's no work. What times itself is 81? That's easy. That's 9. I still have 4 terms. They're just simplified. Now by looking, do we have any terms that are alike? Yes. We have a term here with a square root of 2, and we have a term here with a square root of 2. Those are like terms. Let's put them together. 2 square roots of 2 plus 3 square roots of 2 would be 5 square roots of 2. You do not add what's inside the radical. That's the part that's alike. When you say 2x plus 3x, we write 5x. When you add, the term that's alike stays the same. Now, we also have some constants, -3 and -9. Because they're both negative, we would add, it would stay negative, and we would get -12. Most algebra books will not have the answer written in this order, because in algebra, we like our constant first in radical world. That way, there's no confusion. We know that's a whole number. So a better way to write this expression would be to write the -12 first, and then to write the plus 5 square root of 2. And there is your sum. All right, one more expression. I have cube root of 8x cubed minus 2 cube root of x cubed. So I see subtraction. So the first thing I check to see if my radicands are alike. Even though they're both cube roots, what's inside is not the same. This is 8x cubed, and this is 1x cubed. So they're not alike. I cannot subtract. So if I follow order of operations, I have to work the inside. I got to work the root. So everybody look, we're doing a cube root. So now I'm looking at the perfect cube list. Okay? Is 8 a perfect cube? Yes, it is. What is the cube root of 8? It is 2. Is x cubed a perfect cube? Yes. To variable to be a perfect cube, it needs an exponent that's a multiple of 3. 3 divided by 3 is 1. That's why we write x to the first. Cube root of x cubed. X times x would give us x cubed. Minus, bring down. The 2 we bring down. It's a whole number. We're doing the cube root of x cubed. Is this a perfect cube? Yes, it has an exponent of 3. 3 divided by 3 is 1. Let's rewrite x the first. Or you can think about it as this. What do you multiply 3 times to give us x cubed? It's x. Now, believe it or not, I've seen people do this. This will be the final answer. Read that out loud. That says 2x minus 2x. Are those still like terms? Yeah, they no longer have radical signs, but they're alike. They're monomials. What is 2x minus 2x? Well, it's the same thing as 2 minus 2. It's 0. And there you go. How to add and subtract with unlike radicals. Next module, we'll start multiplying.